guys, so today we are solving this problem, design a stack with increment operation. Okay, so we have to design a stack. So this is the custom stack class that we have to implement. So we have, as you know, we have the push, pop and increment. So push and pop are the usual function of any stack should have, and this increment is the another function. So basically what this increment function does it, so we have first parameter integer k, okay, and this integer val. So if we start from the bottom of a stack, then starting from the bottom till kth element we have to increase the value by val. Okay, this is what we have to do. So we have to implement the push, pop and increment, these three functions. So let me explain what these actually is, what do we need to do. So for example, this is our stack. So right now its size is 0, right? Current size is 0. Okay. So let's say we are doing pop operation. Okay. So pop means to return the top element. But right now this pop, there is no element inside this, right? So what we will return? So if size is 0, in that case it would return -1. If let's say there was some, then we are calling, let's say, push operation, push, push. So basically a max size is given in the array in the question. So let's say the max size is given 5, suppose. Okay, so we would have the 5 boxes, right? We would have total 5 boxes where we can push the values. So if it is going beyond, so let's say size is 5. So suppose first of all I called the pop, but because it is empty, so current size is 0. So if current size is 0, let's say I'm calling it cur size. So if cur size is 0, pop would return -1. So we return -1. Now let's say we are calling push 10. Okay. So if push 10 is there, that means we have to push it. So current size is 0. That means it is not up to maximum size. So we will push this guy 10. Okay. Now let's say we are also pushing some elements like 20, 25, 20, 25, 30, like this. Okay. So let's say I'm pushing. So when I'm gonna push here, it is 20. So now current size would be 2, right? 1 and 2. Now let's say I'm again pushing 25. Okay. So now our current size would become 3. So whenever we are doing push, we have to increase the current size by 1. Suppose we are still pushing 30. So current size is 3 only, which is less than max size. So we can still push it. So let's say it is 30. Suppose we are still pushing 35. Okay. So by now it is 4, current size is 4. So we will come to here, current size, yeah, it is still less than max size, which is 5. So we can still push this guy. So we can push here 35. Now let's say we want to push one more element, suppose 40. Okay. So our current size is already 5, right? So when we are trying to push the 40, we will check the cur size. What is the cur size? Cur size is 5. Which is basically equal to the maximum size of it. That means we can no more push any value. Okay, we can no more push value. And pop, if we want to do pop means we have to basically return the top element. So in this case it is 35, right? So if we are calling pop function, it will return 35 to us. So these are the simple operations. Now we will discuss about the increment function. Now see here, suppose we are calling this function increment 3 and 10. So our k equal to 3. Okay, this is our k and this is our value that we have to increase. So we will start from here bottom. So it is 10. So we have to make 10 plus 10. So it would become 20, right? So we have to make 10 plus 10 here. Similarly, so now we have k equal to 2 more, right? So 3. So till 3. So it would be till here. We have to do total 3 3 elements operation. So we will write here plus 10. Okay, here also it would be plus 10. Okay, so so now our k would be done. So this is what we have to do. Okay, and similarly, if there could be another situation, let's say we had for example, we had only suppose 3 elements available in our stack, for example. In that case, our current size would be what? Our current size would be obviously 3. Cur size equal to 3 in this case. Okay, and max size was 5 anyway. So max would be 5. Now let's say we are calling this function increment like this. So we are calling 4 over here and 10 here. But see here, there are only three elements available, right? So in that case, what we have to do, whenever we are calling this increment function, we have to pass this k in such a way that k should be minimum of either the so k should be the minimum of k comma the current size of it. Okay, because we cannot go beyond the current size, so it would be cur size. Okay, so in this case what we are passing here 4 and the current size is 3. Okay, so it makes sense that we cannot modify 4 elements because there are only 3, so we have to get always the min value where, so this would be 3, so our modified call would be happening over 3 and 10. Okay, so we have to take care of this thing and things would be fine. So we have to take this, that how many times this k is, and then those many numbers we have to increase this value. Like here it is given 10, so I have increased, so this will become 20, this will become 30, this will become 35. This is what we have to do here. So now we will discuss how we should do this. So guys, we can do this thing either using an array, or also we can use the linked list, doubly linked list. So I wouldn't use array, because in case of array we have to give the fixed size, right, whatever size it is. But in case of linked list, we can have the variable size as well, right? So we will create a doubly linked list. And also there is one more importance of this by using the doubly linked list. The one benefit is, like, we have a lot of other questions which can be solved with the doubly linked list approach. For example, like design a LRU cache. So LRU cache also can be done with using the doubly linked list. Similar kind of approach would be there. Additionally, we have to use the hash map in case of LRU cache. Similarly, we have to also sometimes happens like design a doubly like circular and dequeue, right? So those kind of things also can be easily handled using the linked list. So that is why I am going with the linked list approach. Okay, so we will use the doubly linked list here to solve this all problems. So the nodes of our class would be the class node would be like this. Okay, nodes of our linked list would be the basically the object of this class which has integer value, and the previous and next as the pointers, right? We have the any doubly linked list, we have this kind of thing. So we will use the nodes of this class only. So initially our class would be having the two you can say dummy nodes in our linked list, which would be having, I will call head and tail to them. So they will look like some. So these head and tail would be the initial node of our this linked list, right? This would be looks like this. Head dot next equal to tail and tail dot previous equal to head. This is our initial operation, initial linked list. Now when we will call a push, let's say we are calling a push over 10, for example. Okay, so let's say we are pushing to value 10. So we will make a node of this 10, okay, and we will insert it here. So how we will do it? Simply we will just create a node of it. So we have the node having class value as 10, and then we would be adding our these pointers. So head dot next would be this, and this guy dot previous equal to this, and our this guy would be the next and previous, right? We added this. Now we can so cur size, initially what would be the cur size? Initially our cur size was 0, but now because we have added 10, so our cur size become now 1. Let's say we are again calling push. Let's say we are calling on 20. So similarly we have to basically add a like this. We will add a node like this 20, which would be something like this, and something like this. Okay, and our cur size now become 2. Okay, similarly let's say we are making the pop this time. Okay, so if I am making pop this time, it would be returning the first value. So what is the first value here? First value is 10, right? So we have to return, we have to remove this node and return 10 here. Okay, so we will return the 10, but before returning we have to remove this guy as well. So we will write a remove method. So what we would do basically, we will remove this node from here. So now our cut size would again become 1, right? Because we have to decrease because of pop, and this has returned the 10, right? So we have to keep on increasing or decreasing for the cur size. Okay, and max size, we have whatever number value given to us, we have to keep in a mind that our max size, our cur size should not go beyond the max size. Okay, so similarly we have to do all those operations. Now come to the increment. Okay, so increment part, whatever, let's say we have further more nodes, let's say we are taking push of 20 and 30 also. Okay, so what will happen in case of 20 and 30? So our linked list would look like this. Okay, now what we will do, now let's say we are calling the incremental function. Okay, our cur size would be currently, it would be 3, right? Our current size is equal to 3. Now let's say we are calling this increment function on 4 and 10. Okay, so first of all what we will do is we will come to this guy, tail.previous. Okay, so tail.previous is this guy. So from here, starting from here with the previous pointer, we can go up to k size. Okay, but remember, if this is 4, right, so we have to, this parameter should be always the minimum of k and the cur size. Okay, because we might have the entire this value is greater than the current size itself. So what we will do is we have to take the minimum of 3 and whatever cur size, minimum of this k value and the current size, which is 3. So we will pass 3 here. That means starting from here up to 3 nodes, we have to add the this value 10. Okay, so we would be add here 10, so this will become 40. Then our previous pointer will come here, then we will again use here, and k would become k minus minus, right? So k will become now 2. Okay, now we will add 10 here, so this will become now 30, and we will again decrease the k, so now k would become 1. Okay, now our k is becoming 1, and we would be adding here also, this will become 20 plus 10, 30, this would become 30. Now if we again go, our k would become 0, but while loop is only allowing when it is greater than or equal to 1. Okay, so now we can stop it at this point. So we have increased everything. So this is how our code would work. Let me show you the corresponding code for you. So you guys can see here, this is my code. So first, this is our node class, right? And this is our custom stack where we have implemented everything. So you can see here, I just declared the cur size and max size, and I have created 2 nodes, head and tail. Okay, between which we have to create our doubly linked list. So this is our constructor, just assigning the values, max size equal to whatever max size is provided, and current size initially is 0. And these are my 2 dummy node, head and tail, just same this head and this tail, which I have created with the value 0. Okay, so I am creating them, and then initially I am pointing to each of them, each other, and then we are going down. So see here, this is our push function. So first of all, I am checking whether our cur size is less than max size or not. Okay, if it is less than max size, then only I am adding 1 node, add head. Okay, and increasing the current size by 1. Otherwise there is no point of adding any value, because we cannot go more than the maximum size allowed. So we are done with this push. I will show you what this code add at head is doing. Okay, this method, this utility method, I have just written in the bottom of it. You guys can see it here. See here, this is add head. So what it is simply doing is, it's just like we have head pointer here. Suppose this is head, and we have to add something. Okay, let's say there are already some node 1, 2, something like this, and we want to add a new node here. So what it would be doing is, basically this is our finalist tail. So let's say new node n. Okay, let's say this is our new node. So what we will do, we will make this after, node dot after. So this would be our after node, and this is our new node temp. Okay, then see what we are doing. See here, this is our new node. So temp dot previous we will make like this, and temp dot next we will make to this guy, and we will remove this thing like this. So just a second. So you can see here clearly we are just taking the after value in one value, the next value in the after variable, and temp value with the new one that we gonna insert. And then what we are doing, head dot next, we are making this new one, okay, and temp, this is the new one. So temp dot previous I am making head, and the value in the after, what we are doing, the temp dot next basically become after, and after dot previous would be the temp, the newly one added. This is what it is doing. Similarly, we can understand the remove as well. So this is remove at head. This is very simple. So whatever value is there next to head pointer, we are basically removing. So you can check here. What we are doing here is, first of all, we are taking the after value. So head dot next. Okay. So we are taking the second node from the head. Okay, and the next node we have to basically remove it. So what I am doing, head dot next, I am making the second node. Okay, just like this. If let's say we are deleting this node, okay, so what we will do, we will initially we are pointing this, so we have to remove this and we have to point this guy here, and its previous point we have to point like this. Okay, so same thing I'm doing here. So after dot previous is becoming head, and that's it, we are removing the node. So these are two utility functions that I'm using. So come to here. Anyway, this is our pop function. Until our current size is less than till the current size is less than max size, then only we are adding this node. Otherwise we are not doing anything. Then we have pop function. So first of all, we will check if our current size is 0, that means our stack is empty, then I am returning -1. Otherwise, what I am doing, I am taking this x, so this is the value that we have to return. So head dot next dot value, the next pointer to head would have the value which is top value, so we have to return in the pop, and then we have to remove that node. So remove head, just we discuss in the value, and I am decreasing the current size because anyway we are removing that value, and finally we are returning the value return x. Then we have another method, increment. So see here, this is my increment method here. So I have written this function here. So see here, tel dot previous, temp equal to tel dot previous. That is the point where we have to start it, because we have to increase the value by this value for the last k elements of the linked list. That is why I am starting from tel dot previous. So see here, while k is greater than 0, what we are doing here, temp dot val equal to temp dot val plus val, just we did here, right? We increased by 10 starting from here. This is our tel dot previous. Then 3 times we started to the backward direction using node dot previous. Okay, so same thing I'm doing here. So say here we are adding it, and temp equal to temp dot previous, so going backward direction and decreasing the k every time. And then this function I'm directly using here. So see here, you can see first of all, I'm taking the minimum, whatever k value we have to take this k equal to math.min of k and the current size, because if current size is smaller than k, then there is no point of k number of nodes updation. We have to do only up to the max size, minimum size out of these k and the current size. So that is why. So this is all. Let me run my code. Yeah, it is accepted. So let me try to push it. Yeah, so this is accepted the code. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.